So if I wanted to think, if I can calculate natural logs and common logs in my calculator. So if I wanted log of 27, it'd be log base what? Log base 10. Now, common logs are always, we don't write the 10, but it's there. So it's log base 10 of 27. All right, so I can calculate that on my calculator.
Are we recording?
Yeah.
That's what the little
right.
recording thing in the corner
It's like a base 10. All right. So it's video and a sound, so all your comments are coming. All right. So I hit log and then 27 and enter, and that gives me the value. So if I raise 10 to the 1.431363764 power, it would give me what? 27. Okay? All right? Okay? So your calculator can calculate common logs and natural logs. So unfortunately, it can't calculate any other basis. But we have what we call the change of base formula, so that we can change all the other bases into base 10, and then we can plug in our calculator. Okay? So, for instance, if I'm going to do log base 5 of 8, okay? The change of base formula is log base C of A. You take the A at the top and the C on the bottom, and then you just plug in your calculator. Log of A divided by log of C. So for log base 5 of 8, it would be log of 8 over log of 5. Okay? And I would just plug that in my calculator.
That's it?
Where is
so the number on the far right goes on the top, and the one is near the log.
Right, the answer one goes on the top, so, and the base goes on the bottom.
1.292029674.
So, good job, yeah, so you would do log of 8, make sure you close your parentheses, divided by log of 5, make sure you close your parentheses, and you get 1.2920. Okay. All right. Okay.
No idea.
How about log base 8 of 14? Try that.
Okay.
Guys, you're going to need a calculator to do this. Even scientific calculators will do it. You don't need a graphing.
Guys, I got it.
Nate, even a scientific calculator will work. There's one right there.
1.63.
I think you're getting real close. What was that? You're getting real close. Sorry.
Okay, so what would that be, Matt? What would the change of base formula be?
Would it be?
Not the answer, but just what would you write as the formula?
Would it be log 14?
Right?
Or log 8?
Right. Good. Yeah, second row, second column. Okay, and what would your answer be? Rachel, did you get that answer?
1.269. I just closed my phone.
1. Whoa.
Yeah,
No?
that rounded
Yeah.
up.
Oh, log 5. Oh, I did mess up. Yeah, we're good.
Really?
Okay. All right, questions? Change of base? Basically, you just have to get used to the answer goes on top, base goes on the bottom, put it in
It's like a shortcut to what you did yesterday.
It's you can't really solve in your calculator any other base besides 10.
That's 5.
Right. So what we do is we change it to base 10.
So, like,
So means 10 is the exponent. Did you listen to the lesson on Friday? Did you go back and listen to the recording? Go back and listen to the recording and get that whole idea of logs and exponents.
you'll be even more confused after that.
Okay.
That was ridiculous. Hey,
All right.
Question.
Yeah.
So, log base 10
Mm-hmm.
is just like putting a 10 where the 5 is supposed to be,
Right.
right?
Right.
And so, if I were just to put log 8, it'd be log base 10 of 8 in my calculator, right?
If you just wanted to know log base 10 of 8.
So I hit log 8, right?
Yes.
7.9, whatever.
Yep.
Yeah, okay, cool.
Okay. The other thing we're going to do today is expansions. Okay? And to do that, you've got to know. You have to know the log rules that follow because logs are exponents.
Derivative is slow.
Because logs are exponents, they have the same rules. Okay, if you remember our product property, like if I multiply two powers, you add exponents. Okay.
Oh my god.
Well, if I'm multiplying two logs, okay, I'm gonna add. I can break them up and add them together. So the log of x to the m times n is log of x to the m plus log of x to the n. I can break them apart with addition. Okay? So if I wanted to do something like log base 3 of 5x, it would be log base 3 of 5 plus log base 3 of x. Okay? That's first rule. Second rule, if you remember with exponents, when you divide powers, you subtract exponents. So we're going to do the same thing with logs. When you divide a log, you can turn it into a subtraction problem. Log base x of m minus log base x of m.
Right.
Okay?
What about the bottom one?
Okay. So log base 5 of 2/5 is log base 5 of 2 minus log base 5 of 5. Okay? All right, make sure you're writing these rules down, guys, because you're really going to need them. I don't see a lot of pencils going. Write these rules down. You're going to need them. Chris, write these rules down. You're going to need them. Then why aren't you doing it?
Because he thinks he's sweet.
Okay? Okay, the next one, product, or the power rule. When you raise a power to a power, you multiply exponents. Okay? Same thing here. We're going to multiply. Remember, logs are exponents. We're multiplying these two exponents. We're taking the n from the exponent and bringing it out front. So it's n times log x, log base x of m. Oh yeah, we're going to do several. But just make sure you get these written down.
I can't wait.
Make sure you get these written down because when we move up, you're going to lose them. These are just to show you that they're the same.
Do I need to know?
You should have learned them in chapter 5.
Should have been paying attention. I tried.
Okay. All right, so let's see. We are going to expand log base 6 of 5x cubed over y. Okay? The first thing I want to, this isn't really a rule, but it's the easiest way. Do division first. Because multiplication is commutative, so you can switch the order. Addition is commutative, you can switch the order. But subtraction is not. So get your subtraction in there first so you know the order it has to follow. All right, so 5x cubed divided by y, using the quotient property, would be log base 6 of 5x cubed minus log base 6 of y. Okay?
Whoa.
Well, the whole idea is you can bring it down to, yeah, we're trying to get it down to one number, like log base 6 of 5, so that you can use change of base or whatever to solve it. We're not going to do that. You're going to do that in pre-calc.
Oh, I get it.
Yeah, all we're doing right now is just manipulating.
It just looked really scary. Like,
Yeah, it did. I know. Okay, now, if you look at this equation, you've still got some addition or some multiplication in here, so let's take care of that next. Okay, I'm going to break log of base 6 of 5x cubed into log base 6 of 5 plus log base 6 of x cubed. Okay, and I still have the minus log base 6 of y tagging on the end.
Wait, why is that an addition?
Yeah, I don't really get that either.
Multiplication, did you write your rules down?
Yeah.
When you multiply, you add them together. Okay? When you divide, you subtract. When you raise a power to a power, you multiply. Okay? So, back here, we're multiplying 5 and x cubed, right? Those two things next to each other mean multiply. So, because they're being multiplied, I can divide them up into an addition problem. Log base 6 of 5 plus the log base 6 of x cubed. Okay? And the last thing, so far so good. We've got 1 log base 6 of 5, so we have one number. Log base 6 of y, we have one number. The only problem here is this is cubed, so we have to take care of that. So I'm going to change log base 6 of x cubed into 3 log base 6 of x. I'm going to bring the exponent out to the front.
Then are we done?
Yep, and that's it.
Wow.
Okay. And right, that's what it's called. It's called expansion because we're making it bigger and longer. Tomorrow we're going to work on condensing. We're going to take a really big long one and smush it into smaller.
What is that?
Because we're basically, because logs are exponents, so we're raising a power to a power, and when you raise a power to a power, you multiply, right?
Oh, yeah, absolutely.
So we're multiplying 3 times this.
So then, like, why?
Okay.
Like, why
Well,
would you take
because now using change of base formula, can't I guess the actual answer for this? Log base 6 of 5, I could do log of 5 over log of 6 and get an answer.
then log of...
Right.
You can't do that one.
Right. You'd have to solve it. But,
And then you can't do it. Yeah, okay.
okay.
When do we use this? Like, why would...
Okay. Now, this is, like I said, we're learning to manipulate logs. You're going to actually apply them and use them in pre-calc. But we just need to get you familiar with what their properties are, how to manipulate them, so that you're ready for that. All right. This one doesn't have any division, right? So we don't have to worry about division. Okay, it's all multiplication. So I can break it up into what kind of problems? Multiplication means addition. Right, so I can break this up into an addition problem. Okay, what's being added? Log of x squared plus log of y squared plus log of z. Good. Am I done? Right, I have to do something with the squares. Bring them to the front. So it's 2 log of x plus 2 log of y plus log of z. That's it. Okay, you guys want to try this one?
Yeah, let's not.
Yeah, you can.
Wait, is that supposed to be a log or what?
Your first step is to do natural log of 3x to the 4th minus natural log of y, right?
Yeah.
Now, aren't these two things being multiplied? So I can change this to natural log of 3 plus natural log of x to the 4th minus natural log of y. And then the last step would be to move that 4 out front.
Is that an equal sign or a subtraction?
Subtraction. Natural log of 3 plus 4 times natural log of x minus natural log of y. Okay?